This is two videos to talk about how to improve the performance of your Arduino code, or in this case, when you're doing a digital write to an I/O port. And in the first video, we'll simply talk about the impact that digital write, whether it's the Arduino framework or the AVRC framework, has on the speed of the application. And we'll show some frequencies and speeds, then performance there. And in the second video, I'll talk about, okay, so how do you improve that? How do you speed that up by using native commands? So let's look at what happens in a classic Blink sketch. And so you've got the Arduino Blink INO. This is taken directly from their examples. And we use pin mode to set the LED built-in pin as an output. And then we use digital write LED built-in high. So we use this command to set the pin high and turn the LED on. And then we delay right here. And then we set the pin low. It turns the pin off, and then we delay. And that sets up this blink effect. Now, if you comment out the two delay statements, this one and the one below it, then you'll have a better understanding of how long it takes for that digital write to work. And so that's what I did. I commented it out. And using the Arduino framework, I find that we can blink most of the LEDs at 147 kilohertz, and sometimes it runs a little slower. On pin 11, it ran at 119 kilohertz. I just did a sampling of a couple of the pins. And so that is what it is. That's the speed it runs at. And so it's not bad. I mean, it's close to 150 kilohertz. I mean, you can't see that. If you were to blink, 4 or 5 LEDs, you're still well above the 60 hertz range where you'd be able to see it. So it works. It's fine. If you go to the AVRC, which is the same commands, pin mode and digital write, except written in C, I didn't do any optimization. It just turns out the way the code is, but the speed is slightly higher. It's more sporadic. It ranges from 112 to 213 kilohertz. And so by picking the right pin, you can get a higher speed than what you do with the Arduino framework. However, I wouldn't optimize this any greater. If I'm going to optimize it, I'm going to go with the native code, which we'll cover in the second video. But this is really the issue, in that as you begin to do a lot of things with your Uno, you want to ensure that you can, the more things, or the faster you do a particular things, the more things you can do. And that's the concept of multitasking. Multitasking is simply doing one task very quickly, then doing the next task, then doing the next task in such a way that the computer appears to be doing multiple tasks at once. And this works for a Uno with an 8-bit 18 mega 328p, or the fastest, Apple M1 or fastest Pentium chip on an Intel chip. You've got, that's why you go to multiple cores, multiple threads in one CPU, is that so you can speed up this process. Okay, so if we go to the native framework, what does it buy us? It actually buys us almost a 10x increase in speed, at least a 5x if you look at the fastest possible speeds available at 213 kilohertz. With native commands, we can go at 2 megahertz versus 200 kilohertz. And so how do we do that? I'll talk about that in the next video.